So here it has been told to find the position vector of the foot of the perpendicular and the perpendicular distance from the point P with position vector this to the plane this. Also find the image of the point P in the plane. So suppose we have a plane pi1 and its position vector of the foot of the perpendicular from from the point P, whose position vector, suppose here is the origin, and the OP vector, you can call it as A vector, that is equal to that is given as 2i cap plus 3j cap plus 4k cap. It means that the coordinates of the point P is 2, 3, 4. So now we have to find the foot of the perpendicular. Means if PM, suppose it is perpendicular to the plane, then we have to find the coordinates of the point M, that we have to find, and the perpendicular distance also, perpendicular distance PM also we have to find. Okay, so the equation of the plane pi1 is given as r vector dot 2i cap plus j cap plus 3k cap, that is equal to 26, and also find the image of this point P. So we have to find the image of this point P, which is P dash, the image of this point P that we have to find. So then so then here, okay, so suppose let the image, let the image P dash be x1, y1, z1. Then here we can say that, so therefore we can say that this P dash vector that is perpendicular to the plane pi1. This also implies that P dash vector will be parallel to the vector which is the n vector, which is the normal vector to this plane. So the normal vector to this plane is given as 2i cap plus j cap plus 3k cap. So P dash vector should be parallel to n vector. Therefore, we can tell that P dash vector that should be equal to some lambda times n vector. So P dash vector. So if P dash is x1, y1, z1, then P dash vector will be that will be actually OP dash minus OP vector. That is equal to lambda times n vector, which is 2i cap plus j cap plus 3k cap. So OP dash minus OP vector. So this will be x1 minus 2i cap, then plus y1 minus 3j cap, then plus z1 minus 4k cap. So that will be equal to lambda times 2i cap plus j cap plus 3k cap. So therefore, this if we equate the components, so then we will get x1 minus 2, that is equal to 2 lambda, y1 minus 3, that is equal to lambda, and z1 minus 4, that is equal to 3 lambda. Okay, so therefore x1 we can take it as 2 lambda plus 2, y1 we can take it as 3 plus lambda, and z1 we can take it as 3 lambda plus 4. So therefore, the point P can be written as 2 lambda plus 2, 3 plus lambda, 3 lambda plus 4. Okay. Okay, then so therefore this so now here point M, which is the foot of the perpendicular from the point P, foot of the perpendicular from the point P, that should be the midpoint. That should be the midpoint of the image and the object. That should be the midpoint of this point P and P dash. So therefore the coordinates of the point M will be 2 lambda plus 2 by 2. 2 lambda, so it will be x1 plus 2 by 2. So it will be this plus 2 by 2, and comma, this will be 3 plus lambda plus 3 divided by 2, and this will be 3 lambda plus 4 divided by 2. So therefore, which is equivalent to, this will be 2 lambda plus 4, so it is lambda plus 2, comma, this will be 6 plus lambda, so it is 3 plus lambda by 2, comma, this will be 3 by 2 lambda plus 4. So this is the coordinates of the point M. And the point M, and since the point M lies on the plane pi 1, so it should satisfy the equation of the plane. It should satisfy the equation of the plane. Satisfy the equation of the plane pi 1. So now for the point M, the position vector OM vector, the position vector, which is the OM vector, so that will be equal to, suppose R vector, that will be equal to lambda plus 2 I cap plus this will be 3 plus lambda by 2 j cap, and plus this will be 3 lambda 3 3 lambda by 2 plus 4, 3 by 2 lambda plus 4 k cap. So this point we should put in the equation of this plane pi 1, since it should satisfy the equation of the plane. So now therefore you should tell lambda plus 2 I cap plus 3 plus lambda by 2 j cap plus 3 by 2 lambda plus 4 k cap, then dot product of it with we have to take the dot product with this 2I plus j plus 3k, 2I plus j plus 3k, and that should be equal to 26. So then we can write this will be 2 into lambda plus 2 plus this will be 3 plus lambda by 2 plus this will be 3 into 3 by 2 lambda plus 4, that is equal to 26. So then we will get 2 lambda plus 4 plus 3, 2 lambda plus 4, okay, 2 into this and 1 into this, yeah, okay. So 2 lambda plus 4 plus 3 plus lambda by 2 plus this will be 3 3 3 is 9 lambda by 2 plus 12, that is equal to 26. So this will be 2 lambda plus lambda by 2 plus 9 lambda by 2, that is equal to 26 minus this is 12 plus 4, 16. So then we will get this is 10 lambda by 2, so this is 5 lambda. So 2 lambda plus 5 lambda, so this is 7 lambda, that is equal to 10. Okay, so 7 lambda, that is equal to 10. So therefore lambda equals to 10 by 7. So therefore uh, this will be so if we put lambda equal to 10 by 7 here, then we will get uh, the coordinates of the point M we can find, and the coordinates of the point P dash also we have to find. So therefore the coordinates of the point P dash is 2 lambda plus 2 comma 2 lambda plus 2 comma 3 plus lambda, and this is 4 3 lambda plus 4. So that will be equivalent to, this will be 2 lambda So 20 by 7 plus 2, comma, this will be 3 plus 10 by 7, comma, this will be 3 into 10 by 7 plus 4. So this will be sorry, here there is something wrong here. Sorry. There is something wrong. This will be 26 minus, this will be 7 plus 12. This is minus 19. Sorry, this will be 5 lambda. So this is 7 lambda, that is equal to 7. So lambda equals to 1. So for lambda equal to 1, this will be equal to 3, comma, this will be 4, comma, this will be 7. So 3, comma, 4, comma. So 2 ones are 2, sorry, 2 ones are 2, 2 plus 2, that is 4. This will be 4, comma, 4, comma, 7. So this is the required image of the given point, required image of the given point P. And we need to find the foot of the perpendicular, that is the point M. M, it is lambda plus 2, comma, 3 plus lambda by 2, comma, this is 3 by 2 lambda plus 4. So that will be equivalent to 1 plus 2, that is 3, then 3 plus 1 by 2, that is 7 by 2, and 3 by 2 plus 4, that is 2 for the 8, that is 11 by 2. So this is the required foot of the perpendicular on the given plane from the given point P, and the perpendicular distance that is the length PM, perpendicular distance PM, point P is 2, 3, 4. Point P is 2, 3, 4, and point M is this. Point M is 3, 7 by 2, 11 by 2. So this distance we have to find. So PM length will be square root of 3 minus 2 whole square plus 7 by 2 minus 3 whole square, then plus 11 by 2 minus 4 whole square. So this will be equal to square root of 1 square plus 2 3 is 6, that is 1 by 2 whole square, plus this is 2 4 is 8, so this is 3 by 2 whole square. So this will be equal to square root of 1 square plus 1 by 4 plus 9 by 4. So this is 10 by 4. So this is 1 plus 10 by 4, that is 5 by 2. So 2 ones are 2. So this is root over 7 by 2 units. So these are the final answers. Thank you.